concentration of treatment number 1 in the 0 ml, the larvae died in the time of 4 minutes and 43 seconds. Moving on, in the concentration treatment number 1, label 1 ml, the larvae is still alive after 5 minutes. After 6 minutes and 3 seconds, the larvae died in the label 1 ml. In the label of 10 ml, the larvae is still moving after 5 minutes. The larvae died in the time of 6 minutes and 27 seconds in the label of 10 ml. The concentration of treatment number 2, label 0 ml, the larvae is still moving after 5 minutes. The larvae in the 0 ml in the concentration number 2 died around 10 minutes. The larvae in the label 1 ml in the concentration treatment number 2 is still alive after 20 minutes, but it's already weakening. In the label of 10 ml in the concentration treatment number 2, the larvae is still alive after 20 minutes. Concentration of treatment number 3, label 0 ml, the larvae is died less than a minute. Label 1 ml in the concentration treatment number 3, the larvae are still alive after 5 minutes. The larvae died around 10 minutes in the label of 1 ml in the concentration treatment number 3. In the concentration treatment number 3, label 10 ml, the larvae still moving after 5 minutes. After 12 minutes, the larvae died in the label of 10 ml in the concentration treatment number 3.
In this laboratory, we prepared 3 different treatments. Treatment 1 for plant-based pesticide, which is the chili pepper. Treatment 2 under BTI, which is the neem leaf extract. And treatment 3 for the available insecticide that will be used to expose in the mosquito larvae to be able to determine their effectiveness and observe also how these insects react to the treatments we prepared. As a result, among the three different treatments, the level of toxicity coming from the available insecticide shows to be the most effective way to harm, irritate, and kill the insect we collect. For just a few seconds of exposing the available insecticide to the larvae, we easily observe and see how the larvae die slowly. On the other hand, the other treatments we prepared, which is the neem leaf extract and the chili pepper based pesticide, shows also its own effectiveness in suppressing insect, but unlike the available insecticide, the effectiveness of these two treatments to the larvae was not quick as the available insecticide shows. Therefore, I conclude that in terms of controlling insect, it is much way effective if we use the available insecticide because of its toxicity and chemical it contains. Moreover, we can deny also that this insecticide that we tend to use or apply can also harm some beneficial insect, environment, and the health of the applicators, so it is better to have a control in using and applying this chemical-based product.
In laboratory number 4, it is like a research. You need to do a pesticide using plant-based. Then you need to explain what will happen if you do a plant-based pesticide. Then compare it for the treatments to the insect that available. So in treatment 1, the plant-based pesticide, wherein we use hot pepper. For treatment 2 is the BTI toxin, which is the neem tree extract. And the treatment 3 is the conventional insecticide. For the insect, we use mosquito larvae. So, this activity, you need to gather data in every 5, 10, 15, and 20 minutes. Then, record that data. Then, you see if the plant-based will be effective. So, in our plant-based pesticide, is shown effectiveness, but not effective as an insecticide. But they can also suppress the insect mosquito larvae. Also, we can say that the plant-based is not quickly to kill insect, unlike in the insecticide. Therefore, I conclude that if this activity is working as face-to-face, like with classmates and professor, I think the plant-based pesticide will be more effective. For the activity, show up that also you can do a plant-based pesticide to our plants and crops in our home.
In laboratory experiment number 4, we make beta concentration to be insecticide in mosquito larvae. The plant we use is chili pepper and neem tree. This is effective to kill mosquito larvae, but one of them is harmful effect in human is the neem, because the smell is giving a fragrant smell and mosquito they attract to it, and the chili pepper is super spicy. When you touch, did not mean to you different part of your body. And the last is mosquito insecticide. You buy this in any store to kill mosquito and spray. It is this most harmful because bad smell, toxic, and we can cause of death. This is very harmful your health. Most effective in the tree is the neem tree. Therefore, I conclude this experiment is to show what are the best applicable insecticide in mosquito larvae that no harmful in your health and no show the harmful insecticide that can be cause of death of human, animals, and the environment.
This laboratory activity number 4, we collect some mosquito larvae in nearby field. Our group used mosquito larvae as a specimen, and we use 3 treatment of BTI, which is treatment 1 is plant-based insecticide and treatment 2 is neem tree extract BT toxin, and treatment 3 is chemical pesticide. Then, by using of the three treatment, we see the final result, which is more effective in killing the insect larvae. But we all know by using some chemical, we had a bad effect in our body or in our farm. All we know that pesticide is usually used in their farming and they are using it. Though chemical insecticide are suitable too. Let us think before we apply them and see the content before we use them as treatment.
The group used three different treatments: the plant-based, BTI toxin, and the insecticide. Using these three treatments, we observed the movement of the larvae and which treatment is the most effective in killing mosquito larvae. As the result, among the three treatments, the most effective is the chili pepper. In this treatment, the larvae died faster than other treatment. The laboratory experiment shows that different pesticides can also kill or control pests even there in the larvae stage. Therefore, I conclude that using organic pesticide can also kill insect larvae. It also gives an idea that we can control the pests in their larvae stage. This laboratory experiment also shows us that larvae that exposed in insecticide or organic pesticide are slowly weakening and died eventually.